Well, can you see my presentation?
Yes, yes.
Well, I use in my presentation a few slides from Alexander Krasovsky speech at Geodigital Ukraine in 2019. And this part of our geodetic theoretical background is about uh, one famous American company, Trimble. This is very uh, huge company which has um, begun its navigation uh, equipment uh, working out on 1983. First of all, you can see here a few examples of the modern, uh, nowadays it's not modern, but ancient equipment. You see it's very first of GPS satellite receivers. And here you can see the evolution of global navigation system receivers from this corporation. You see that not only design of the antennas has been changed, but the equipment become much more powerful. Modern equipment allows everybody to get the coordinates of every point with high accuracy and very quickly. Here you can see the development of field portative computers, so-called controllers. These controllers are universal equipment to control GPS or total station in the field. You see that during these years, new technologies, new operation systems have been used in this hardware, and nowadays the Trimble company is well known all over the world. And also we have at our department Trimble GPS equipment. So it works with under modern operation systems. This equipment has broad variety of interfaces, for example, USB, Bluetooth, Wi-Fi, etc. Here you can, in this slide, you can see a kind of advertising and explanation how the triangle techniques and in any case every geodetic technique help uh, people in different kind of economy in agriculture, uh, so-called precise agriculture, in forestry, um, accounting and monitoring of forest resources, in water utilities, business, creating and surveying, making accurate uh, maps and plots of water and other city utilities. Civil construction, this construction machines has GPS receivers on the board, and so um, it helps to construct new buildings and roads very precisely. Rail business, uh, field service, building construction, geospatial applications, mapping, GIS creation, transportation and logistics, environmental pollution and working to protect our natural environment, electric utilities and telecommunications, mining, oil and gas and chemicals, in governmental governing the territory in different fields. We need spatial coordinates. In the slide, you can see the evolution and modern urban survey methods. There are a few examples of global navigation satellite system receivers, total stations, robotic, automatic total stations, and hybrid of total station with scanner system. And scanner system mounted on the roof of a car, so we can get the 3D model of the city environment, and this is also modern geodesy. In this slide, you can see the hybrid of total station with scanner and this combination triangle A610. This equipment can do all the assignment as a robotic automatic tachyometer and laser scanning system. Well, the result of scanning system is so-called point cloud. The active element of this scanner system rotates quickly, and it measures the angle and the distance to the points around this scanner. Another solution is very high point cloud density with complementary immersive imagery. Um, this scanning system get its precise spatial coordinates with advanced GNSS and inertial technology while the car is moving underground. Um, the inertial technology allows to get the coordinates of every center of projection of these scanning systems. All this family of hardware is compatible with existing Trimble software and workflows. Also, they present software for trigonometry, for photogrammetry, sorry. What does it mean, photogrammetry? Photogrammetry, it's a measuring of photographs that have been got from different places, from the outer space, from the space shuttles, from the airplanes, from the drones, from the ground. And this photogrammetry technique allows to get the point cloud and 3D model of the territory. Another option is so-called technology of mixed reality. It means that you can not only imagine but really see the projected buildings outside while you have special equipment or special glasses. They combine the reality which you see by your own and with the 3D models of future buildings and construction elements. So this 3D technology allows to see the future interior or exterior of future buildings. Trimble Corporation allows to connect the workers using the Trimble Connect. It means that all the measurements have been made in the field. All the coordinates and all 3D models going by internet to the main office, and all workers can see the project in the natural environment. The solution allows to accurately overlay all our BIM data directly on site to identify issues faster, track progress, and ensure quality installs. Please does everybody know about BIM technology and what does it mean? If you know, please type down plus in the chat in any, or minus if you don't know nothing about BIM technology. Yes, you know about BIM. Can you explain me what does it mean BIM technology and what it's mean for construction? Hello?
So, what is BIM technology is like? It's some modeling of buildings.
Yeah.
And in the soft on the computer, which make a process of building construction is easier and more comfortable. Like you can count different. You can count how many materials you want. You can see 3D model of the building and stuff like that.
Well, however, your answer is not complete because BIM technology means building information modeling, and it helps to work with all the stages of building life cycle, from the projecting, construction, and then use of the building, and then reconstruction or demolishing of this building. So all these BIM models allows to create so-called digital twin of the building. So this digital twin helps to yes, you can see the possibility of use of these models, for example, in Autodesk technologies, in AutoCAD Civil 3D, and other software. However, these models are very useful for utility modeling and utility exploitation in the building. All the repairment of the electricity, water supply, gas supply, etc. It makes more comfortable using this digital twin of the building. Well, let's move on. And here you can see examples of special HoloLens by Trimble. It's also advertising that you can see the BIM model over directly over the real environment of the building. That help us to understand all the complexity of these different uh, equipment and different utilities. Well, another example of modern technologies in geodesy, it's Hexagon Corporation. If you try to find the information about the Hexagon geosystems, it's I also use the presentation from the international conference in Kiev about geodetic technologies. Well, Hexagon is a kind of umbrella corporation that has as its parts um, many companies that produce hardware, software, and services in the field of geodesy and GIS technologies. You can see the history of Hexagon company. I am not sure, but I think that the main office of Hexagon is situated in Switzerland. Well, they have been spoken about the history of their part companies that become the parts of Hexagon Corporation. It's Kern Technologies. It is the beginning of the 19th century. All the geodetic and surveying equipment. Then the Wild Company in Germany, and this you can find a huge amount of wild theodolites in the museums. Now it was very precise and good equipment. And also you probably know the Leica company. It's probably about you can hear about precise and with apparatus for making pictures, photo cameras by Leica, and they have the special branch in the Leica company, so-called Leica Geosystems, which is working on the geodetic equipment, software, and services. And Hexagon company had bought the Leica Geosystems company, and nowadays they together are working on digital solutions in different branches of geodesy and GIS technologies. Nowadays, all the geomatic techniques means not only geodesy but also the Earth exploration from outer space, so-called remote sensing, and different solutions that connected with aerophoto images getting, mm, working with drones, and so etc. Well, every modern company uh, nowadays should propose not only data but also services and solutions for customers. Because if you got the spatial data about the construction, about the new building, you also need some software to work with this digital data. Because nowadays all the data exists in digital form. Well, Hexagon also uh, propose different services and makes different solutions. They have special software and hardware for different purposes. Here you can see short list of these advanced technology solutions. UAV mapping solutions, laser scanners, leveling. You can see digital level from Leica Geosystems. GNSS reference networks. Well, we should next time we will speak about GNSS receivers technology, and you can see that we need special infrastructure for use these receivers, so-called GNSS reference networks. These networks can be situated on the ground, reference stations. Another option is the translating of transferring GNSS reference information from another sources, from satellites, for example. Special lasers for construction. It's a kind of digital equipment that makes the horizontal and vertical visible surfaces that construction workers can use directly in the process of building construction and room interior establishing. Line and point lasers is special geodetic equipment for construction. Then can project the vertical lines to zenith and nadir, and helps to precisely construct buildings. Different sensors, hybrid sensors and LiDAR sensors, small scanners that maybe 20 centimeters height, total stations, special field GIS collectors that helps to combine all the data from the field into the one mutual environment. Detection systems that helps to find underground utility networks. Small pocket laser distance matters for construction purposes. Mobile sensor platforms in the backpack, for example. Special GNSS systems, machine control systems that helps to control all these building machines, detecting systems, mobile sensor platforms, constructions, and total positioning system and global navigation satellite system. Mine slope radar helps in different geological investigations, etc., etc. Well, modern technologies allows to transform surveying with a true innovation and new categories. First of all, we can create broad portfolio and get loyal customer base. So these customers can see the future project of the building. Solutions connecting the digital with the real world. It's so-called virtual reality. True innovation for mainstream. All the equipment on the construction field do not work separately. All the equipment work inside one digital project, and it's very similar to modern military operations when everybody see all the picture of the construction if necessary. Also, you can give every person different levels of security, and every person get all necessary for him data. Expanding to new markets. It's international company, growing importance of 3D modeling, and creating new category radar for geodesy. Last years, the main technology was LiDAR because they use the light laser beams, and also another technology is radar technology for geodesy. It also allows to get very precise data of environment. Airborne imaging from airplanes, a huge amount of digital area photograph cameras, airborne lidar, uh, getting the 3D point clouds, mobile mapping, also using lidar technologies on a car, in backpack, on a drone, etc. Huge amount of drones and so on. Well, while speaking about digital construction and geodetic technologies, we can see that the main problem of nowadays technologies is connecting different data sources in one environment. It's evidence. It's evident that the huge amount of data should be processed by powerful computers. But while the data processing will finished, we can visualize digital Therian model, digital surface model, orthophoto images of the city, 3D models, and 3D mesh. It's a kind of grid that approximates the real landscape of the territory. Well, Therian Mapper is a new generation of LiDAR systems. It has high efficiency, good data quality, the possibility to capture any LiDAR object, efficient multi-sensor workflow, and so on. Well, here you can see Frankfurt, Germany fused elevation and intensity data that have been got from different sources. First of all, from scanner systems. Also, scanner systems helps to get high planimetric accuracy for rail infrastructure and documentation, and so on and so on. Here you can see all the digital cameras. Here you can see City Mapper. And mobile reality capture solutions broaden addressable market. Here you can see the Leica scanner, which allows to get a point cloud of the city. And specific solutions. Yes. Well, modern geomatics companies allows to get uh, different levels of accuracy for different purposes. Uh, it can be 3D surface mesh. Mm, uh, it can be shown for customers, for future partners who will pay the money for new project. Very accuracy elevation model that allows to model canalization and hydrology and hydrography, um, hydroconstruction, and so on. Uh, Precise orthophoto imagery from um, aircrafts, for example, 30 centimeters in pixel, it is spatial resolution of the images, 15 centimeters and 5 centimeters from a drone. Here you can see main products that should be taken using modern geodetic or geomatics technologies. It's aerials images, it's oblique images of the territory, it's elevation models, and it's 3D meshes. Here you can see result of aerial imagery coverage across the Europe. Smart digital reality, and it's the end. And now we should move forward, and we will speak about LiDAR technologies, so-called LiDAR or laser scanning. What does it mean, laser scanning? Laser scanning or LiDAR, it's a technology of for obtaining transformation about the relief and objects of the terrain using a laser beam. The result of laser scanning is a cloud of points of laser reflections. The main purpose of the LiDAR is creating of digital terrain models and, uh, and digital uh, elevation models. Um, Here you can see the difference between digital territory models and digital elevation model. Digital elevation model shows relief of the Earth's surface without trees, without buildings, without cars. Uh, it's bare land without any another objects. Uh, on the other hand, the digital terrain models, let's digital elevation models. We have stationary laser scanning when shooting the device installed motionless on a tripod. The measurement is made from several points of standing. On the other hand, mobile LiDAR technology, when shooting device is installed on a ground or water vehicle. It can be car, railway platform, or boat. The measurement is carried out continuously during the movement of the carrier. And the essence of ground laser scanning consists in measuring distances from the scanner to the points of the objects and registration of the relevant directions, vertical and horizontal angles. The result of the system is a cloud of points of laser reflections. Well, the ground laser scanning shooting we use for shooting of individual objects, engineering structures, buildings, architectural monuments, etc. Mobile LiDAR technology allows performing shooting of linear objects, highways, railways, power lines, river banks, etc. Speaking about aviation laser scanning, we have aircraft with GPS equipment on a board. This precise, you can see triangle antenna, for example. This precise global navigation satellite systems allows to get the coordinates of the aircraft, and the laser makes one impulse and few reflections. First reflection from the trees, second, third, and the last one, fourth reflection from the ground. All these reflections have different intensity. However, this technique allows to precisely and with high productivity and high accuracy get the information about all the features on the territory. There are few advantages of the method. High level of automatization of data collection, obtaining accurate results in hard-to-reach places, obtaining detailed information about the relief under the vegetation. It's one of the main advantages because another data sources don't allow to get the ground information about ground under vegetation. Here you can see different laser scanning methods, um, uh, different media, aircraft, helicopter, or drone. It's aviation scanning, mobile scanning, road, railway platform, or boat, and stationary ground scanning. We use tripod for mounting the scanner system. All the three methods have different vertical and horizontal accuracy. Aviation method allows to get accuracy from 5 to 13 centimeters. Mobile scanning 2 3 centimeters, and tripod mm, 0.3 0.5 centimeters. However, this accuracy is shown on the uh, mean distance from the scanner to object. For stationary ground scanning, this accuracy we can get while the scanner stands on the 20 meters from the surface. While the scanner stay much on a much more distance, the accuracy become lower. Uh, all the scanning methods allows different performance. How many shooting in 1 hour. Of course, the aviation scanning method allows to get the biggest performance. It can be 100 to 200 kilometers along the track of the aircraft, and approximately from 10 to 30 square kilometers per hour. Another level of performance gives to us mobile scanning. It can be 40, 70 kilometers. And the stationary ground surveying has the lowest performance. However, all the techniques we use for different purposes. Shooting large planar and linear objects, we use aviation scanning. Shooting linear and local object, we use mobile and stationary scanning. The main applications of the aviation LiDAR method is production of orthophoto maps, 3D modeling of cities, executing of design and survey works, design, monitoring, and inventory of linear objects, forestry, water management, mining industry, bathymetry, making the maps of the water bodies and the bottom of the water body. Mobile and stationary scanning allows to get 3D models of individual engineering structures and technological equipment for reconstruction of architectural objects and monuments, monitoring of buildings and structures, monitoring and inventory of roads and railways. and also in mining industry. And here you can see the informativeness of laser scan, its comparison of aircraft laser scanning and ground laser scanning. You can see the different points accuracy. Ground scanner is much more accurate. On the other hand, the ground scanning gives to us much more. The point cloud has much more big density. Well, we use nowadays the combination of LiDAR survey and aerial photography. It allows to one aircraft has the equipment of laser scanning and aerophotography. Well, cloud of point of laser reflections can be classified by intensity, by color, and by a different type of objects. For example, building roofs, gardens, roads, etc. In the slide, you can see the features and benefits of aviation laser scanning. The first example is SRTM. Does anybody knows what does it mean SRTM? Or I should show you examples.
Show us examples.
Well, SRTM means SRTM data. SRTM means the shuttle radar topography mission. It's a low resolution radar data from outer space from special satellites. You can download these data freely. For example, from NASA. And you can work with this data in QGIS environment, for example. I will show you. It's very easy. Well, today I have been download this data directly from NASA, and just a moment. let me show you how does it works. Here you can see Earth Data Explorer, which allows to download different free data from the servers. It different satellites, SRTM. You must to get your personal account on the Earth Data NASA.gov site. Clear. Find data. You can try to find different data sources. Here it is. Here you can see the visualization of SRTM data in GIS environment. So the accuracy of SRTM data is kind of 10 meters. Every pixel of the SRTM image you can see this different parts of the SRTM imagery, and as you probably can see, here it is the territory of Romania and Transcarpathia region. It's Carpathian Mountains, Svidovetsma Mount Massif. Here is Petras, Gaverla, and Chernogora Massif. Every single point of the image is average height of the territory above sea level, which have captured using satellite system. Well, let's move on. So this SRTM data is free. You can download it from NASA sites. The point density is low. It's about 90 to 90 meters. And this model do not show all the peculiarities of the territory. This finished product, it can be downloaded from open sources. Another kind of data. It's remote sensing data. It can be much more accurate. The point density is in between 1 and 50 meters. It also can show the vegetation, for example. Another step is aerial photography. The model can be created from the huge amount of aerial photographs. It's so-called photogrammetric data point cloud. It has from accuracy, point density from 5 centimeters to 2 meters, and accuracy about from 1 meter to 10 centimeters. And the best accuracy has the aviation laser scanning, because it allows to get all the data about relief peculiarities and the data about vegetation and all the features on the ground which you want to get from remote. The ground scanning is much more accurate, as you probably can understand. Well, the applications of LIDAR, of ground LIDAR and aerial LIDAR systems is cartography and photogrammetry, increase the productivity of photogrammetric work, because we can get the accurate 3D elevation model and photographic working with all these photograph images will be much more accurate. Creation of them, digital elevation model, it is because it is a basis of orthophoto transformation. Data about relief, creating of detailed dam in places covered with vegetation, water management and flood protection, forecasting of river floods and design of flood control structures, flood protection due to global sea level rise, creation of digital models of engineering and transport infrastructure. For example, power lines and highway and railway infrastructure, architecture, creating of 3D models, surveying, determination of the different structures, quarries, dams, forestry, determination of tree heights and biomass volumes. First example of aerial laser scanning application is electric power industry. You probably know that all these power lines should be under control of engineers, because they need to have free so-called security zone about 25 meters from the power line axis to the left and to the right. So the use of laser scanning allows to measure all the dimensions of the power line, the size of the stand, the size of the traverse, the height of the stand, the dimensions of overhead lines, the actual length of the wire, etc. So the production of data for assessing the condition of power lines means construction of three-dimensional overhead line models, construction of longitudinal and traversive profiles indicating the violation of the dimensions of the overhead electric power line, compilation or clarification of the coordinate catalog of the centers of overhead supports, drawing up a diagram of the state of vegetation in the area of the boundaries of the protected zones of this power line, preparation of recommendations on clear forest cuts, quality control of clearing works, drawing up a scheme of threats to the stability of power line. For example, landslides, soil erosion, disassembly of elements of supports, etc. Scheme of vegetation in the area of the boundaries of the protected zones of the power lines and areas of vegetation to be cut down according to the documentation. Another application of laser scanning techniques means water management. You probably know that Russian military forces had destroyed the dam in Kryvyi Rih, and the water level have raised, and the water damaged some engineering infrastructure. The water management allows the government to get the digital model of the relief of the river basin. One of the convenient technique of the geodata for water management archive creation. Its main products, first of all, digital elevation model, integrated digital elevation model, and digital terrain model. We use these models for water management and water resources management, the basins for determination the territory of catchment and watershed, integration, certification, and accounting of water management facilities, basis for hydrodynamic three-dimensional modeling, flood treats, design of flood protection facilities, and modeling the boundaries of flood in the territory. Here you can see the modeling of the water rising by 2 meters and by 5 meters on the real territory. And here you can see the boundaries and the area of flooding territory. Another application is forestry. Well, you probably know that the forestry is nowadays one of the drivers of the economical development in some countries that has forest on its territory. For example, it can be Canada, Brazil, and the western Ukraine, where they provides clear cuts or total forest cutting, and then they use the wood for different industrial purposes. The main goal of the laser scanning data in forestry is forest taxation or forest taxing. That means that understand all the peculiarities, all the dimensions of the forest in the particular area. The main parameters that can be get from the spatial laser scanning data is three heights: the volume of wood stands biomass, vertical closure, horizontal closure, density of standing trees, predomination of tree species, formula for a combination of methods for forest taxation or taxing. Aerial aviation laser scanning, remote sensing, digital aerial photography, ground survey, and finally we can get information about forest. Here you can see profile of different trees of different heights, so-called levels of the forest, the determination of the completeness of the forest stand. Every tree top can be get from LiDAR data. And also we can determine the tree species, for example, oak, alder, maple, and so on. Beech forest. And the main applications of laser scanning is photogrammetry and cartography, because we can get the precise digital elevation model and digital relief model. We have much more LiDAR allows to raise the productivity of orthophoto maps creating. Here you can see the rising of productivity while using airborne LiDAR data in 3 times approximately. Well, we can speak about performance, authenticity, detail, and accuracy of data. The automated process of LiDAR data processing allows one to speed up the creation of digital elevation model by more than 3 times compared to the photogrammetric method of creation, reducing the influence of human reliability factor during processing data. The high detail of digital elevation model is achieved due to the ability of the laser scanner to push through the vegetation, creating a detailed microrelief of areas covered with vegetation, and accuracy, large altitude accuracy of digital elevation model is about 5 to 10 centimeters, in contrast to photogrammetric method of construction where the altitude accuracy depends on the resolution of aerial photography. Future application of laser scanning data is, for example, automotive autopilot. LiDAR data can help a vehicle to get the picture of the road environment, and these real-time data sensors and allows to get all the necessary information for unmanned car driving. Well, on this good news for you, we can stop the presentation. I thank you everybody for listening. If you have any questions, please. If you have not, well, thank you for your attention, and goodbye.
Thank you. Goodbye. Goodbye.